Today's lab is going to require a lamp with tinfoil, the small hole cut out, a meter stick with the 0 centimeter mark at the lamp, the 100 at the far side, and a Labquest. Our Labquest is going to be the device that's picking up our light. To turn on the sensor, click Sensor, Sensor Setup, and select the light sensor. When you're finished, hit OK. Now the sensor is actually located in the top left of the Labquest. We can cover up with our finger to see if it works, changes the number, and release it. We're also going to need to know how to zero our Labquest, and do that by touching the screen, hitting the 0 pop-up, and as I'm just mistakenly done, make sure you don't cover the sensor when you're doing that. This way it gives you a good base value. Let's hit the lights and actually get to the lab. The first thing we want to do is find 32.6 centimeters. Take our Labquest and we're going to zero it. Make sure the sensor is lined up with the light. We're going to zero it because this is our baseline. This is where all stars would be lined up if we're finding their true luminosity, or their absolute value or absolute magnitude of brightness. So let's zero that. And now we're free to move our Labquest to the different markings where we're getting our readings. The first one is 10 centimeters, or we're going to pretend it's 10 light years. The brightness of the star is 425. At 20 centimeters, the reading is 83. At 30 centimeters, the reading is negative 33. At 40 centimeters, our reading is negative 35. At 50 centimeters, our reading is negative 45. At 60 centimeters, our reading is negative 63. At 70 centimeters, negative 65. At 80, negative 65. And at 90, our last measurement looks like negative 67. Let's look at our worksheet. We're going to go ahead and fill in lamp number 1. We could do the exact same thing with a second lamp, or like I suggested, you could use a cell phone as the second lamp, and we wouldn't use the standing lamp to get our data. Don't forget, if you do use a second lamp, you do need to zero the Labquest at 32.6 centimeters again for each different lamp chosen. On the x-axis, we're going to put the centimeters or light years. On the y-axis, we are going to place the luminosity numbers. These are the ones that we gathered. Now, you realize that we're going by 50s each block, and we start with a negative number because our lowest data is in the negatives. Kind of like a number line, we're going to see the negatives towards 0, and then 0 towards our highest number of 425. But we need to be within that range. We plot our points. And we're going to create a line graph. Makes the most sense for this sort of data. I'll choose a different color here to do that. And let's look at our summary questions here at the bottom. What is our dependent? What are we measuring? We're measuring luminosity or absolute brightness. What is the controlled variables? We kept the same lamp. We kept the same sensor that we're using. Or we kept the same scientist or students in each group. And we also kept the same place in the room. What patterns do we see? And if we looked at the graph, we saw that the numbers actually went from high positives to low negatives as we went further away from the lamp. And lastly, why do results differ between groups? Think about it. We have different bulbs in each lamp. One bulb might be new, one might be old. We have different areas in the room. Some of you guys were by the window, some of you guys were in a darker corner of the room. And part of it is accuracy. Some of you guys were exactly at 32.6. Some of you guys were near 33 or 31 centimeters when hitting 0.